Hey guys, we'll be talking about CQRS microservice architecture and we'll take a deep dive into it. So first we'll understand what is the CQRS design pattern, how it works, and what is the need of it, and why to use it, and when we can use it. What is the use case for it? And then we'll try to understand what is the disadvantages of the CQRS, right? And then we'll see one real-time example with the CQRS, and then we'll end up with our thoughts. So what is CQRS exactly? The CQRS stands for Command Query Responsibility Segregations. What is referring for the write operations? Query we are referring to here for read operation, and for the segregation basically for the read operations. Like we segregate, then we read it. So that's how we do call as a command query responsibility and segregations. It is a pattern that separates the reading and the basically querying of data from the writing or commanding of the data. In this architecture, different models are used to handle reading and writing operation. While this concept can be applied to various types of applications, it is particularly useful in microservices architecture to enhance the scalability and the performance. So, why we need to separate read and write operation differently? What is the use of it? And is this really need to do it? If it's need, then for what type of application it is, and how that will help the application. So we'll discuss in details step by step. So think about a system like traditional system where you get a request from the interface, right? You get a request from interface, then you get a request from interface, then read and write operations happens in a single funnel. Single model perform both read and write operation, right? And it is like single data store for it. Then read and write operations. But let's say there is a heavy read operation or heavy write operation, or you want to basically scale the read operation, or maybe you want to scale the write operation, depend on your business case and business needs, or maybe you want to put some limitation or restriction, or maybe structures for this read operation and write operation differently, or maybe you want to apply security layer differently for the read or differently for the write operation. Then how will you do it? Because in this traditional system, you have a single system or single model for the read and write operation, right? So this is not possible at all. So to simplify this, we came up with the CQRS model, where C means it's command, it's basically go for the write. Q means it's basically read operations, and then we say responsibility segregations, right? This is here how we define. So how this is advantage for the smaller system? To be honest, this is not helpful at all for the smaller application or medium-sized application. When I giving a figure like small size or medium size, it's depend on the transaction I'm classifying it, right? So it's only helpful for the bigger application, or where it's important, like it's a kind of read heavy application or it's write heavy. If read and write composition like 1:1, or could be it is small to medium size application, then CQRS is not the right solution for. Probably you could go for the traditional approach where a single model can be shared for both read and write operations. So let me talk about how exactly the CQRS model works internally. See, when we receive the request from the interface, let's say write request from the interface, then the command service trigger with the events, which will be like event store. Then it will publish to the message broker or the message service Then there will be consumer which will consume and seek to the read replica. This could be different DB than this write DB. Write DB could be only like a relational, could be SQL, could be MySQL, could be SQL Server, could be PostgreSQL. But at the same time, read replica could be your NoSQL DB, which collects more metadata or aggregations, or it could be flat tables. This really helps for the read, for the better performance, right? So, or you could use Redis, also a good fit for it, right? This is the overall concept of CQRS. So we'll go, what is the key concept, right? So basically commands, operations that modify the state. Example, create, update, and delete, basically the write operations. The queries operations that retrieve the data without modifying it, right? So it's just read it, right, without do any CRUD operation. The command model handles the commands and manage the business logic for the state changes. The query model optimized for reading and presenting data in a way that suits the client or the application needs. That's I explained. Event sourcing often paired with a CQRS ensure that all challenges to the application state are stored as a sequence of events, allow the system to reply the events and reconstruct the current state. What is the need of this event sourcing, right? Event sourcing, right? What is the need of this? See, the moment any write operations happens in the system, you have to sync to the read replica. And what sequence? So you'll be publishing, then it will go to the message broker like Kafka, RabbitMQ, or it could be according to your business case and your budget or your resource constraint, or so you could do it. Try to suggest Kafka would be the good solution for it, right? Again, Kafka brings a lot of complexity into this. So the moment event has consumed and pushed into the read replica, but what sequence you will get the data and push to the read replica to update? In that scenario, you need to maintain a sequence, right? And this has to be in the asynchronous process, right? In that scenario, we have to use this message broker or event store, right? So that's what you are highlighting here, event sourcing, right? So when to use CQRS? CQRS fit for complex domains, high-scale systems, and microservice architecture where you need to optimize the performance. You want to include into event-driven systems. In this category, if everything gets fixed for you, case 1, case 2, case 3, case 4, case 4, and case 5, then only you can go for CQRS. So what is complex domains exactly? When the business logic is complex and requires different models for different type of operations, then the product domain itself will get complex, right? So to simplify it, you need a two different funnel or maybe two different model to conduct the read and write operations, to scale the read and write operation, put a limitations, put a authentication, securities, right? You need for that. So high scale systems, when the read and write operations scale differently and require independent optimization, then probably CQRS would be the solution for you. Similarly, microservices architecture in distributed system where each microservices can handle its own data and services. CQRS enables decoupling the read and write responsibilities, which is really helpful to bring the performance for heavy read and or write operations or for the bigger application. The performance optimization. When the system requires a heavy read operation or complex queries that can be optimized separately from the writes, then this is definitely help your performance to increase, right? Or bring them better performance, right? When system needs to respond to events or maintain a history of changes, then you need to maintain a sequence of it, right? So for that you require event-driven systems. And then you maybe some message got corrupted, or you want to recover it, or you want to exactly monitor what sequence you got the events, what sequence you process the image, or how to rollback it. In that scenario, you need this event-driven system, right? So what is the advantage of CQRS? So if we talk largely, what is the advantage? Separation of concerns, optimize read and write operations, scalability, flexibility, right? So by separating the commands and queries, each model can evolve independently and simplifying the maintenance and enhancing the scalability of the system. The read and write models can be independently optimized, so there is no dependency now. It's totally completely decoupled, right? For the instance, read models can be highly denormalized for the faster queries, while the write models are designed for the consistency and integrity. So basically, you said the read operation will have from this funnel or this model, and the write operation will happen from this model, which will make sure that consistency, integrity maintained across the distributed system. Then there is a scalability. As the read and write operation or workloads can scale independently. So once your workload or the resource usage goes high, or your workloads goes high, then how you will exactly manage to optimize your read or write operations? The moment it goes high, you have enough scope If you are into CQRS, you can scale both read and write operation differently. You could put a security layer on top of them and differently. You could do a lot of optimization on that side. Flexibility on the data storage. It's not mandatory now for read and write operation. You should use the same data storage, right? Because it's decoupled. For the read operation, probably you could use like kind of SQL, or maybe like it could be MongoDB or could be Redis, right? And the similar way for the write, for atomicity, integrity, for acid nature, you could use the kind of relational DB. Could be MySQL, could be SQL, so could be PostgreSQL, right? I explained this enhanced security and even sourcing also I explained. Let's go to the disadvantage of CQRS. It's increased the complexity. Yes, of course, it's increased the complexity because you introduce a lot of components, different data storage, different communications way, right? Communication burst. It's definitely it is a complex infrastructure, then complexity will be increasing because you need to monitor a lot of things, right? Managing two separate models for read and write increase the complexity of the system and requires more development effort. Yet, to be honest, yes, to manage this each component, how this application side, component side, deployment side, you need a extra effort to complete this or follow this CQRS. Data synchronization. Ensuring consistency between the read and write models can be challenging, especially when the system is highly distributed experience and high latency. Yeah, that's true. So when in a high distributed environment, read and write operation to do in a mass ways, it's totally difficult. You have to conduct a lot of read and write operations. There will be locking and all these things. Now you are totally free out of it, right? You could do read and write totally independent. Duplication of logic, yes, there could be a high chance you duplicate your logic since the models of reading business logic might need to be duplicated or handled in more complex way. That's true. Potential overhead, yes, managing multiple data stores for the command and the query basically for the read and write operation can result in additional overhead in terms of infrastructure and maintenance and synchronization. Not always necessary in smaller systems. That's I explained. For the smaller application, you don't have to go for CQRS. If it is not like read heavy or write heavy or application, you don't have to go for CQRS. The moment you feel the application is big, you need to deal with a huge transaction and in distributed environment, then probably it's read heavy or write heavy operation. Then probably you could go for CQRS. Because it's being a lot of complexity, you have to introduce a very rich logging system, telemetric services, right? And if it is done completely, how it works and how it's breaking and so on. So you have to write for a mechanism like if any events get corrupt, then how you'll recover out of the logs, so, right? So these are very complex. This bring a lot of complexity into this CQRS design pattern. To the real world use case and examples for it. While in e-commerce platform, the order processing system is very write heavy, and the same time product catalog, you just fetch them, right? It's read heavy. Different, it has a different requirements. The order system needs strong consistency for the transaction. Definitely for the order transactions, you need a consistency, atomicity into the transaction. While the product catalogs requires efficient queries to handle, because you have to catch a large number of requests to product with different filters, then it's require a kind of heavy read operation. So the two system can be optimized independently, enhance the performance and scalability. Banking and financial system. See, in a banking application, the account transaction model like commerce, it's right, requires a high consistency and validation. Example, preventing overdrafts. On the other hand, system, the queries, the read operation requires a fast access to account balances, transaction history. The CQRS allows these two functionalities to scale and evolve independently, enhancing the both performance and readability. Likewise, social media applications often need to handle heavy read operation like creating post, liking a post. In such a case, CQRS allows the read model to be highly optimized for the user's engagement with the denormalized data structures that optimize for the frequent and complex queries that users perform. Let us go for the example of CQRS in a particular case. Imagine a simple order management system using a CQRS in a microservices environment. Like, it's just like command model or which is write model and query model which is read model. They differently functions. There is a you could scale them differently. They are completely decoupled. In case of command model or write model, the service could handle all write operations such as placing an order, getting the order status, or processing a payment. It uses a transactional database like SQL to ensure that these options are consistent, these actions are consistent and reliable. Similarly, the query model, the read model, this service is optimized to provide real-time access to the order data, allowing users to view order history, status, and related information. It may use NoSQL database like MongoDB for fast retrieval, and Redis, as I said, Redis also could be good for it, right? To denormalize the data. By using the separate module for commands and queries, the system allows each service to scale independently, handle traffic efficiently, and optimize for its specific operation. So the thoughts will be CQRS is not mandatory for all microservices application. It's only applicable for the distributed, heavy, bigger size application which conducts a lot of transactions, and it could be read heavy or write heavy operations. So then you get enough scope to scale your read and write differently. And you could put a security layer, you could do a lot of optimization, you change your query structure, or you could put some additional layer maybe if you are using MongoDB for the DB. On top of that, you may add some Redis case the data. So a lot of optimization you could do once you put your transaction into this CQRS microservices design pattern. I hope clear the basic concept of CQRS microservices design pattern. If you have any points or you want to clarify anything, put everything in the comment. And thanks for watching. Have a good day. Thanks.